Everyone, and welcome back to part two of our unit circle. Today we're going to fill in 16 more coordinates on the unit circle using patterns, what we know about sine and cosine, and whether the values are going to be positive or negative. So in the last lesson we saw that the unit circle has a radius of length 1, and that the sine is the y-coordinate and the cosine is the x-coordinate. And that tangent we can find by dividing sine by cosine, but tangent is not on my unit circle. It's just the slope of the hypotenuse. So the first thing we're going to look at, there's our picture of the unit circle, is if we know the angle here, and the angle here is going to be 30 degrees, for example, we have a special right triangle. We have a 30, 60, 90 right triangle, and we're going to use our rules to find the special side lengths. Those are going to be our coordinates. So we're going to see some numbers repeated a whole lot of times this lesson. Now, as a quick reminder, the sine value is the height. It's the y-coordinate. The cosine value is the base. It's the x-coordinate. We got to think about where is it positive, where is it negative. And we remember that the tangent is not any part of any coordinate. It's the slope, which we can find out by rise over run, or sine divided by cosine. We'll deal with tangent later on. So now let's take a look and explore. Okay, this is our unit circle. There's a lot of symmetry going on. There's a lot of equity. There's a lot of parts that are in common. So my question is, what other angles are at the same height as 30 degrees? Either above the middle line, this middle line here, or below it. So 30 degrees gets me a height here. What other angles have this same vertical distance? It could be going up, or it could be going down. Try to think of the other three angles. Label them on your unit circle, or write them in your notebook. So I have an angle of 150 degrees, which is also 30 degrees above a middle line. It's 180 minus 30, because I want to be 30 degrees before 180. So 30 degrees and 150 degrees are going to share a lot in common. Now there's two more angles that I'd have to go down for, so I'd have to go 30 degrees more than 180, which would be 210. And if I almost wanted to get to the full circle, but I was 30 degrees short, I'd be at 330 degrees. So 30, 150, 210, and 330 degrees all share a lot in common. 30 degrees is considered the reference angle for all four of these angles. So we're going to call that the reference angle. What that is that's an acute angle, an angle less than 90 degrees that's in the first quadrant that shares properties with 150, 210, and 330. The only difference is they're going to have the same sine and cosine values, except sometimes we're going to have negative values instead of positives. Now, to find the points on the unit circle, we need to look at these special right triangles. Now, a previous lesson we did special right triangles, but if we had a 30, 60, 90, we called it x square root of 3x and 2x. We are now going to just divide everything by 2x to get the hypotenuse to be 1. So if we divide by 2x, we get 1/2. If we divide this by 2x, we get square root of 3 over 2. And if we divide this by 2x, the hypotenuse, we get 1. So this is the special right triangle, but this is called a unit triangle where the hypotenuse is 1. So we're going to need to remember 1/2 and square root of 3 over 2. And for a 45, 45, 90, we're going to remember square root of 2 over 2. And I have some ways to help us remember those three numbers as well. But these three numbers are going to be the ones that show up all over my unit circle as horizontal distances, so as cosines, and as vertical distances, as y values, as sines. So if I copied this unit circle into here, I dragged and dropped it. If this is a 30-degree angle, I have coordinates. And there it is. I copied it on there. So if my hypotenuse is 1, then my height is 1/2. My base is square root of 3 over 2. So that's what it's like as a coordinate. It's square root of 3 over 2 for x, comma, 1/2 for y. And now I know the sine and the cosine of 30 degrees. The sine is the y coordinate, so the sine of 30 degrees is 1/2. The cosine of 30 degrees is square root of 3 over 2. Now let's say I forgot which order the coordinates go in. Well, does the 1/2 come first or the square root of 3 over 2? I like to visualize and think, is the base longer or is the height longer? In this case, the x is bigger, the base is bigger, and square root of 3 over 2 is bigger than 1/2. So I think it is a big or small, okay, the smaller is across from the 30 degrees. So I can visualize, okay, the y coordinate's 1/2, and if we're looking at the y coordinate, we're looking at the sine. Now think about what this 150-degree angle looks like. What are the coordinates? Try to fill them in. If you know the 150, do you know the 210 and the 330? Start filling those in. Okay, the 150-degree angle, the only thing that's different is that the x value is negative because we went to the left instead of the right. The height's still the same. The height's still positive. So if I know the sine of 30, and I know this, I also know the sine of 150 because they're at the same height. They're both up. They both have a positive y, so they both have a positive sine. Cosine is the same magnitude. It just has a negative sign in front of it because the x-coordinate's negative. And the 45-degree angle is very similar. Okay, except those are not square root of 3 over 2 and 1/2. Don't do that. Those are square root of 2 over 2. Both of them. It's an isosceles right triangle. Both of these lengths are the exact same. This is the middle. So square root of 2 over 2 and square root of 2 over 2. And likewise, we can figure out what the other angle pairs are in the second and the third and the fourth by doing some calculations on what is this number, how far behind 180 is it. It's 45 degrees less than 180. We can calculate the number. We put the angle measure, we can put the coordinates, and then we know that the sine and cosine are both positive here, but they may not be positive everywhere depending on, do I have a positive height going up or a negative height going down? So now it is your turn. I want you to take probably 10 minutes, fill in this unit circle, understand the concepts, think about where the negatives go, where the positives go. What does the special triangle look like? Which angles match up, for example, 30 and 150 and 210 and 330, and fill in this unit circle. There probably will be still one more line where we talk about radians in the next lesson, but for right now, I want a whole bunch of coordinates and a whole bunch of angles. Take your time. When you're ready, you can unpause the video, and I'll have a filled in unit circle for you to take a look at. There's our unit circle. Now don't worry about this pi over 2 or pi over 3. These are called radians. We're going to talk about them in the future. But you have angles. You have coordinates that we filled in last video, and then we have 30 degrees and 150 degrees, and the x coordinates, one's positive, one's negative. And down here for 210 degrees, they both have the same coordinate, but both are negative. So negative square root of 3 over 2 compared to positive square root of 3 over 2. Negative 1/2 compared to positive 1/2. So we're going to use these three triangles, the 30, 60, 90, and the 45, 45, 90, and the 30, 60, 90 again, just with reverse coordinates, to fill in the whole unit circle. And remember, the cosine of the angle gives us the x coordinate, and the sine of the angle gives us the y coordinate. Now we'll continue to practice the unit circle and the concepts, but this is going to give us a strong basis to anything else we can do with trigonometry.